Today we're going to look at how to solve quadratic equations through the factoring we've done in previous lessons. Before we get into that, let's just have a quick recap of linear equations and finding x and y intercepts. So in our recap problem, we're asked what is the x-intercept of y equals 2x plus 4? And we know that y equals 2x plus 4 is linear. We can also see that the equation is in slope-intercept form. So we have a slope of 2, and we have a y-intercept of positive 4. Now I've drawn the graph out, and we can see here, if I start at the origin and go up 4 units, 1, 2, 3, 4, there's my y-intercept, and the coordinate for that is 0, 4. The x-intercept is at, if I start again at the origin and go to the left, it's at -1, -2. So it's at -2, 0. So we can see here graphically that when I have a y-intercept, my x value is 0, and we have a value for the y-coordinate. When I'm looking for my x-intercept, the x value is there, but the y-coordinate is 0. Now, it's always nice to have a graph like this to be able to determine the intercepts, especially if the graph is a very neat one, where the red line travels perfectly through a whole number or integer on the x or y axis. But we might not always have the time to draw a graph, and the line may not always travel nicely through points. So we can do this algebraically as well. So if you recall, to find the y-intercept, we know that the x value will always be 0, but there will be some number representing y for the y-intercept. And what we did previously was we would say y equals 2 times 0, because the x value is always 0, plus 4, and then we solved that equation for y. So we would end up with y equals 4. And sure enough, you can see we've got an x of 0 and a y of 4. We can apply the same logic to the x-intercept. And as we showed on the graph, we'll have some number for x, but the y value is always 0. So instead of replacing the x with 0 in the equation, we replace the y value. So this would become 0 equals 2x plus 4. And then we solve for x. We end up with x equals -2. And again, right, I have an x value of -2, a y value of 0, and that matches exactly what we had on the graph. So that's how we can do it algebraically. So how does that recap fit into what we're doing today? Well, our goal for today is that we're going to find the zeros of a quadratic equation. So what are zeros of quadratic equations? Well, essentially, these zeros of a quadratic equation are the x-intercepts. The zeros of a quadratic equation are the x-intercepts. Remember, a quadratic equation produces a graph that is a parabola. Now, in the particular example I have over on the right, this parabola opens downwards, so it has a maximum at its peak, right? The maximum would be right here, but it also has two x-intercepts. One over here at -3, 0, and the other one over at 3, 0. This is our maximum. This is an x-intercept. And we have that other x-intercept. So our task today, when we're finding the zeros of a quadratic equation, is to find the x-intercepts. And we can do that in much the same way we just did up here. When we're looking for an x-intercept in a linear equation, we replace the y variable with 0 and solve for x. And that's what we're going to do today. So here's our first problem, finding the zeros of a quadratic equation. And we have the equation y equals the quantity of x minus 2 multiplied by the quantity of x plus 5. And as I said, we're going to solve this in much the same way that we did with the linear equation. We replace the y value with 0. And now I need to solve this for x. And the way that I can do that is, I want to know what values of x would lead for me to end up with 0 as the final answer. And this is all multiplication. Now that's important because if the right side of the equation is the quantity of x minus 2 multiplied by x plus 5, that means if this x was a value that when we subtract 2 leads to 0, this would end up becoming 0 times x plus 5. And as we know, anything multiplied by 0 is 0. So to determine what goes here, and we can figure this out mentally, what minus 2 would be 0? It would be 2, right? And we would do the same thing for the x plus 5. What plus 5 would equal 0? It would have to be -5. So there would be two answers. But the way we can show our work is like this. We just break the problem down into two equations there where we're going to solve for each parentheses. What would make each parenthesis equal 0? And obviously this is a basic equation. We end up with x equals 2 or x equals -5. So these would be our answers. And again, we could figure that out mentally up here just by using some math sense. What would have those parentheses come out to a total of 0? So again, what this means is if we have, I'm just going to sketch out a graph here. If we've got a graph, we have a parabola that would cross over, let's say, -5 and 2. All right? So the parabola is going to go through here. And that's what we've just found. We found the x-intercepts for that parabola. In the second example, we have x squared minus 25 equals 0. If you recall back, this is a perfect square binomial. And we know that as a special case, we can break this down into x plus 5, the quantity of x plus 5 multiplied by the quantity of x plus 5. And then from there, we would break it down into the two problems again. And I know that we can do this mentally, but just to show the algebraic process, all right, subtract 5 from each side here, we would do it like this, especially for much more challenging problems. So our answers would be, for this one, we have x-intercepts of -5 or +5. In our third example, we have the quantity of 2x minus 8 to the second power equals 0. So I'm just going to expand this one out so we can see what it is a little better. And we know that it would be the 2x minus 0 multiplied by itself. So I really only have to do this one once to determine what that x value must be. And then I solve this equation. And I've got an x-intercept of 4. And you'll notice there's only one x value. On all of the other problems, we had 2, right? So what does that mean for this? It means we have an x-intercept of 4, 0. It means our parabola would look something like this, where the parabola comes down and only touches the x-axis once. Okay, our last example, 4x squared minus 15x plus 15 equals 0. So in this problem, we have a perfect square trinomial. So that means we have to factor it. So what we're looking for here are, and if you remember, we have to multiply the 4 times the 15, so that's factors of 60. We need factors of 60 that add up to negative 17. Well, we could do negative 20 times 3, but that would be negative 60. Even though we get negative 17, so it's not that one. We could also do negative 12 multiplied by negative 5. That would equal positive 60, and they add up to negative 17. So that's what we'll do here. We'll break this down. And I've grouped them as I did it. And then we can pull out our common factors. So in the first set of parentheses, I can factor out 4x, and that leaves me with x minus 3. In the second set of parentheses, I can factor out a negative 5. And that will also leave me with x minus 3. Bring down my x equals 0s. And now I can factor out the x minus 3. That's in common with both of them. And I'm left with 4x minus 5 equals 0. So now that we've got to this point, we would work as we would in all of the previous problems. We'd have our 4x minus 5 equals 0, our x minus 3 equals 0. Obviously, this one is x equals 3 here. X. And on the other side, we would add 5 to both sides. 4x equals 5. Divide by 4. X equals 5/4. So these are the x-intercepts, and that's it. We're done. So there's various levels of factoring involved today. But again, we're finding the x-intercepts, and we're doing it in much the same way we did for a linear equation. And this is our task today. If you have any questions or need any help, shoot me an email, and I'll get back to you as soon as I can.